Mechanical engineering.
Rachel, industrial engineering.
Mariana, industrial engineering.
Laura, civil engineering.
Margaret, environmental science.
Mary, mechanical engineering.
Lautaro, business.
Billy Wilson, anthropology.
Krishna, IIT Bombay.
Tavish, mechanical engineering.
Kara, political science and international affairs.
Casey, civil engineering.
Annie, neuroscience.
Shahid, civil engineering.
Hi.
Nice to see you again.
Carissa, chemistry.
Devashi, civil engineering.
Trisha, civil engineering.
Eric, finance and math.
Anik, civil engineering. Freedom, civil engineering, environmental science.
So you have a lot of variety.
And Ken is civil engineering.
A lot of variety. There was one person who could not come, he's a little bit under the weather. But we have almost everybody here, as you can see.
Yeah, it's a very good mix of different disciplines.
Yes.
Thanks, Orup, for
Thank you very much.
inviting me. And thanks everyone for your introductions. So as Orup mentioned, I'm Monika Jain. A little bit background about myself. I'm an architect and urban planner. So I've worked in cities from Bangalore to San Francisco, Los Angeles, and latest was in New York till from 2007 to 2012 with the Mayor Bloomberg's administration. I was working in the city planning department, and then I came here when the center actually was being envisioned as part of a sister center at IIT Bombay and CUSP, which is at New York Center for Urban Science and Progress. So I'll talk a little bit about that as well. So my talk would mainly focus on three aspects, mainly centering around what Center for Urban Science and Engineering is, how it was envisioned, and what are we planning to do in this center. And then IIT Bombay, how we are using our campus itself as a living lab. And then I'll talk about the Solar Decathlon competition, which IIT Bombay and Academy of Architecture team is participating this year. And also the future of the world. Today we have half of the population living in urban areas. In India currently we are 30% in the urban areas, but it is going to increase. And so this is, if you see this graph, the red one is the urban population and the yellow or the green is the rural population. Especially in Asia, the rural population is migrating towards urban areas and the urban population is increasing. And if you look at just India, we will be adding almost 500 million in 4 decades from 2010 to 2050. So that is, and you've been going around in Mumbai for maybe 2 or 3 days, and you must have seen how populated the city is. So we will be adding almost, theoretically, 38 such Mumbai cities in the next few decades. So that is a big challenge. And you've just gone to, you all are in Orup's class and talking about climate change. So this is a big challenge for the climate change itself. As more urban you go, the higher the resource demands, higher the energy demands, and that is going to increase the climate change. So these are just some glimpses of what's happening in the Indian cities and especially in Mumbai. Happens at construction. You guys visited Dharavi. So how packed houses there are and the conditions of health and sanitation, you must have been able to gather from there. So there is a lot of slum development in urban areas and a lot of urban poor population that is increasing. The water to the cities comes from long distances. So if you consider IIT Bombay, we are getting our water from 150 kilometers up. And similarly, the Mumbai cities today, we are lacking almost 90 million liters per day. We have deficiency. So there are plans to actually get water from further places, and areas like slum areas, people do not have enough water supply. So this is how the water is carried for the urban poor and also in the rural areas. actually steal water from the pipes that run along. This is the situation of traffic, and this is when only around 10% of people use their own vehicles. Most of the people either walk or use the public transit. Mumbai public transit system is very good, but it is overcrowded. It carries almost 10 times the capacity it has. So this is a challenge, and if we keep growing, and this is the way we keep growing, then there is no place where you can actually accommodate the growing population. Mumbai has 4 months of rainfall. We get almost 2500 mm in 4 months period, and in 2005 there was a very disastrous event when it rained almost 1000 mm in 24 hours time. 5,000 people died. So, but this is a situation where climate change will actually have these events occur frequently, and people will be stranded. So flooding and sea level rise are other challenges for the peninsular India, where there are lots of coastal cities along the peninsula of India. So these are some of the challenges, and what do we have to focus on if we want to design resilient cities? The building construction, how the relationship between land use and transportation is, how the infrastructure networks are laid, water supply, energy supply, and the waste system of the urban areas, and then the urban resource flows. Where does our water come from? Where does our food come from? And overall, how much energy are we using in all of these resources? So these are some of the challenges that we have to think about when we think about designing resilient cities in the light of climate change. So the need of the hour is better planning and design, better policy and governance, better infrastructure, and better informatics and technology use. So our CU's overarching goal is to really look at all of these 4 aspects together and make it a people-centric research. So look at the quality of life of the people, considering all of these 4 aspects. So, and our goal is to really do interdisciplinary research, which is applied. Like you look at the real life problems, the real life projects, and try to gather around multiple experts, look at the stakeholders, use science and technology along with planning and design. Our goal is also, so with these 2 we are looking at the urban challenges of the developing. So these are just some of the broad areas in which our center would focus to research on, but combining these 4 different circles. These are, so it is actually, we are lucky to be located in IIT because we already have many science, engineering and technology departments that are quite established. So we are sort of picking faculty and researchers from the existing departments to make our core interdisciplinary team. We are also collaborating with the municipal governments since we are in Mumbai, with Mumbai and other cities, academic institutions and universities, NGOs and other advocacy groups. As I mentioned, we are part of the CUSP consortium, which is led by New York University, and it has other 5 universities around the world, as well as industry partners. So that makes it a strong consortium. And McKeep, which is a partnership of 28 universities. So this I'll run through very quickly, just a glimpse of what kind of research projects are going on at our center, and I'll go into a little bit detail in the first one. If this mouse moves.
Otherwise, Tarish can.
Yeah, no question.
Okay. So how do we, so the second one, in case of flooding or fire, how do we really optimize the location of the emergency response teams, the fire and the police and other things? So that is we are using technology and policy as a combination and trying to develop that infrastructure for certain wards of Mumbai, and then we can expand it to a bigger location. How can we have privatized healthcare which is affordable? So there is not enough of government hospitals and government clinics that are available. So people who are living in slum areas, there is a slum area right outside IIT. How do we actually provide affordable and socially inclusive healthcare? So we research area is the slum area outside IIT. Empowering citizens to monitor urban spaces. So urban spaces, if they are designed properly and used well, that can actually create a community feeling. So how do you use technology to empower citizens to maintain and police these spaces? And the next two are about how do you design your buildings, design your spaces so that you can address the real estate dynamics as well as try to address the events like flooding. And then this is more about, so I don't know how many of you understand floor space index, maybe several people might. Okay, no, not you. Anyone else wants to, floor space index or floor area?
It's just kind of like square footage available for people to live on.
Okay. That's correct. So if you have a plot size, say of 100 square feet, how much square footage you can build on that plot? So that is the total divided by that plot area. So that's how the floor area or the floor space index is calculated. So a lot of this is given for free if you build, say, parking areas. So how do you really innovatively use this in terms of giving out area free for different public uses? So in New York, for example, there are lots of public plazas that are developed by private entities for public use by making use of the additional floor space index. So this is an example of an innovative policy. So let's look at IIT Bombay. I think you have gone there twice now, and you might have gotten a little bit sense of the main road and some of the academic building. So we are around spread around in 500 acres. We are 18,000 population, which includes students, faculty, staff, and their kids. Then we have over 100 buildings, actually more than that. So there are zones of academic area, residential area, there are hospitals, restaurants. So it actually is like a mini city. So there is a lot of scope of experimenting what you would do outside in the city in our campus. So our overarching philosophy or the method is to look at the design. It could be design of the building, it could be design of the transportation system or the different spaces. Understand its usage wherever you are able to measure it, and then through either sensing technologies or through surveys, and then try to use that measurement into design improvements or efficient operations of the different spaces or policy changes, which again then feeds back into the design of different spaces or systems. So now, this is my particular research that I am looking at in the campus. Why focus on buildings? So there are more than hundreds of buildings on campus. And if you look at the overall energy that buildings use in the world is around 30%. And today in India actually, so this is again the world statistics, 45% is used for just heating, cooling and lighting of the building. So that is a huge amount of energy that is being used by people. 5% is used in building construction, and this is important because more than half of the construction is going to be in India and China. As you saw that the population increase in the urban areas is actually going to be the maximum in Asian cities, where India tops. What do you guys understand by urban heat island? Anyone wants to?
It's warmer in urban areas than it is in rural areas because of
a bunch of different things.
Like,
Density and cars and the height of buildings and transport.
okay. Why would it be hotter in urban areas because of all of those things? Just go a little bit deeper.
Lack of vegetation, dark colors absorbing light, pollution from the cars, emissions from industries.
Good. Anyone else wants to add something?
Well, like the pavement also, it like reflects a lot of the heat, and in between the buildings, there's like, it like maintains a lot of the heat at night as well, in between the tall buildings.
So all very good answers. So yeah, the urban heat island is that the urban areas are a few degrees hotter than their counterpart rural areas, which are just located a few kilometers away. And so I'll speak more in terms of how buildings are contributing to it. So this is again example of our campus. I don't know if yesterday when you went to the Nano Center, if you walked through the Infinite Corridor. So this is one of the places in the Infinite Corridor in that building where air conditioning units are just lying, and if you walk there, I don't know if you noticed or not, you'll feel the hot air sort of coming through. And this is the place where a lot of cows actually just relax and spend their time. So a lot of this is happening in and around the world, in fact, where old buildings are being retrofitted with air conditioning systems without really considering the tightness of the envelope. If you see around in Mumbai, a lot of glass buildings. I don't know if you have noticed that, but the Mumbai climate is such that you don't really need the glass buildings because it creates a greenhouse effect where it will capture a lot of the solar radiation. And then if you see, there is a lot of buildings with concrete brick, which is thermal mass, which actually captures the heat and radiates it out in the evening time. Since Mumbai climate is not very different, the day and night climate, so it doesn't let the heat release sort of in the atmosphere. So that heat also remains in that urban area. So all of these different aspects, other than what you guys mentioned about pavements and vehicles and all, contributes to the urban heat island effect. So a lot of these things are in our control when we design buildings adequately according to the climate. So you look at where you are located. If you are in the tropics, you really don't need lot of glass facades. In the northern or the temperate climates in New York and all, it would be beneficial because you are using a lot of heat. It is a colder climate. So you look at that, we look at passive ways of heating and cooling your buildings by the way of designing your buildings. And if you must have heard about green buildings, right? Do you want to, can I ask you questions?
Please.
Okay, who wants to take a stab at defining what are your understanding about green buildings?
We had an example of that in Jordan, basically a building that like conserves energy and whatnot. So basically the walls would be insulated, the windows would be double glazed so that they can insulate the heat or the coolness, so you don't have to have heat on or the AC on for long times. And depending on where it is, sometimes it would have more glass outside or not glass. That's
Very good.
Design buildings in general just have zero emissions, whether it's energy by using solar, wind, or anything like that, rainwater reuse, and just having no effect on the environment when you're replacing a building.
Very good. Anyone wants to add anything? Both good answers. So if we actually design our buildings sensitively to the climate that they are in, you can actually reduce 3 times the amount of CO2 emissions that are required by the Kyoto Protocol. So this is just a summarization of what green buildings could do. They can save energy, as you mentioned, with the insulation and the double glazed windows. They can produce energy through solar, wind, bio, and a lot of other means, save water, through conserving water as well as recycling the grey water and black water. They can capture rainwater in a Mumbai kind of climate. It would be good to have rainwater captured or stored on site. Create open spaces. Most of the roofs of the buildings are not really used, so you can use that to either create open spaces or produce your own food, at least the vegetables that are perishable that can be grown easily. So this not only saves money for the people who are living in the building, but it is also good for the city as a whole. It saves on the infrastructure needs and it brings people closer to nature. So there is a lot of advantages of designing your buildings in a sensitive way. So I'll now come to the campus and give you just one example of what I'm doing with my building research on campus. So we have looked at several buildings on campus. The sixth one is the one that you went in yesterday, Nanoelectronics building. So what we are actually doing is, so this is an example of the guest house in the campus where we are looking at what is the building material, what is the orientation of the building, north, south, east, west, how high is the building, details of what kind of lights are used, what kind of appliances are used, and also looking at the actual annual energy usage of the building. We're modeling that building with all of the details of the materials, the orientation, the windows, how many windows on what side of the building, and trying to come up with the modeled energy usage, which is divided by how much is the energy used by appliances, how much is it used by lighting, fans, cooling, which is the air conditioning systems, and the hot water needs. So this is the breakup of the, and then we match these two to make sure that what we are getting through the model is according to what the actual energy usage is. So if actually, let me go back to the previous graph. If you look at this graph of the model energy usage, what do you see here?
Uses the most energy in the peak of summer.
In the summer, there is the most energy used, which is kind of April, May is the, anything else? Yeah?
All usage is pretty much the same throughout each month besides the cooling.
Besides the cooling. So cooling is the most dynamic load, except and everything else is kind of the same. So that is a major point. In the winter months, the cooling is negligible, but that is the dynamic load. So why is there cooling load so much? Yeah?
Just because it's so hot. Is that what you mean by your question?
Yeah. I mean, in terms of the building, so building is actually getting the heat that is outside inside. So there is a lot of heat gain, and there is either through the open windows, but the red one is through conduction, which means that the external surfaces of the building, the walls, the windows, roofs, they are allowing a lot of heat to enter the building. So we break it down further and see how much heat is being gained through these different elements of the building. So walls, in this case, the walls form the maximum surface area of the building. Walls is the maximum, glazing is the windows, the roofs. So we look at all of this, break it down, and then try to see how we can improve our building to reduce these loads. So, so this is just showing you the first one is the base case as the building is. Option one, if you just improve the windows, so right now it's single glaze, if you did double glaze with air gap in it, it will improve the cooling loads or reduce the cooling loads by 11%, and the time it will take you to actually recoup the cost that you put in replacing the windows is around 4.5 years. So similarly, if you just put in very efficient ACs, you would reduce the cooling loads by 26% and recoup the cost in 4 years by the energy savings that you are having. So similarly, you can actually do this analysis for each and every building on campus and try to make improvements. So I've done this analysis. I take green building class at IIT, and through the help of the students, we have done this analysis for around 15 buildings, trying to understand the building usage first and then trying to see how we can retrofit it. So this is the building roof. We can also look at how you can actually design the roof to allow for production of energy, the solar panels and the solar thermal panels. And then since this building is actually located just next to the Kovai Lake, I don't know if you have gotten a chance to go there. But it's a beautiful view, so you can actually use the roof for putting green roof and some seating areas, so you can enjoy the view, create more open spaces. And the green roof itself will allow insulation so the heat came through the roof is reduced. So this was just one example of how you can actually improve your buildings. And the other thing that we are doing is, so making these investments without really knowing if our model is correct or not would be not a very wise idea. So what we are also doing is collecting real-time data through wireless sensors on temperature, humidity, air quality and other stuff, and validating the models that we have so that the implementation that we do is based on the real data. This is an example of, and what we also want to do is actually provide information to the users through display so that people know if I entered this building, how much energy I'm contributing to, or how much this building is using, how much it is producing. All of this information so that people are aware of their use of energy. So that was just on the building side of what we are doing in the campus, how we are using campus as a experimental lab. So this kind of model can be expanded to be used in new building construction in the cities, in different cities. So this is a model that can be expanded to various other places. You guys must have heard about solar decathlon, right? No? So solar decathlon competition was started by US Department of Energy in 2002. And it takes place every 2 years. Now there are counterparts in Europe and China started last year. So Europe was started in I think 2005 or 7. So this time the Europe one is happening in Versailles, France. And this is the first time an Indian team is participating in this competition. We are called Team Shunya. It's a consortium of IIT Bombay students, faculty and Rachna Sansad Academy of Architecture. And our house is called H0, so Zero Energy Hub. So our goal in the campus is actually to use this house as a green building laboratory. So these are the 20 teams participating all around the world. A lot of interdisciplinary teams coming together. So this is the house which we have actually built on the campus. Now it's already shipped to France. The competition is in June, July. So there are various systems and all of the things that you guys talked about, what green buildings are, have been incorporated. It's a small house of around 70 meters square or 680 square feet to be precise, for 6 people, which is 2 parents, 2 children and your grandparents visiting. So that is the culture in India. And we are also looking at how this prototype can be used in the Indian context. So there is an industrial corridor that the government is investing a lot of money in, which runs from Delhi to Mumbai, which will reduce the amount of time it takes for the freight to move from 14 days to I think 14 hours. So this gives an opportunity for a lot of townships to come around this area. So this is the corridor that we are targeting, how this house prototype can be part of a bigger sustainable township. And we are looking at a place called Uran, which is around 1.5 hours from Mumbai. So this is the house which is the top story of a 4-storied building, and how this 4-storied building fits into a larger urban context. So we've done, so we have built the house, but we have done analysis with simulations and with other analysis to see how much energy we are actually reducing by building like this. So it will be almost equivalent to not avoiding the production of 79 gigawatts of power, which is, I just converted it before coming here, it's around 40,000 million US dollars saving per year. So this is a little bit more detail of the house and how we are making sure that it is energy conscious as well as it reflects the culture of India. So Vastu Shastra is a very old traditional science of India where it says how the functional spaces of the house should be able to actually light the 90% of the house in the daytime without using any artificial lighting. So all of this has been used to design the house with the simulation technologies, and what we find according to the simulations, the real measurements will happen in the competition time, that it uses 60% less energy than a conventional house in India. These are some of the, maybe some of you would be able to understand this, but we have the solar panels on the roof of the house which actually traps the sun. So it becomes much more efficient, so 26% more efficient than a static panel. We have the solar thermal which has phase change memory balls which actually retains the heat, so you can get hot water even in the night time when the sun is not around. Similarly, we have tried to use some of the innovative technologies in the house. Okay. These are some of the interiors. What we have tried to do here is make sure that we use the local craftsmen and artisans and local material like the bamboo and cane which is available in India to actually reflect the Indianness of the house. So this is one of the previous years in the US, I think, but this time it will happen in front of the Palace of Versailles. So this is how the different teams actually make their house, and we have 10 days to build the entire thing, and then there is a 15-day evaluation period where anyone is allowed to visit. So in case any one of you is in France at that time, you should come and visit. So, so that was more focusing on the buildings and how we are using our campus as an experimental laboratory. I'll just give you a glimpse of what other things that we are doing on campus. Some of the ongoing activities we are using. So we have 15 hostels where a lot of food waste is there, vegetable cuttings are there, so that is being used at a prototype level to convert waste to energy. Waste recycling is happening. There is a lot of scope of improvement in all of these different aspects. You must, I don't know if you noticed, but there are pathways and some benches and also a building that is being constructed through the construction debris that is produced from the buildings that are being renovated. There's a urban agriculture lab which is experimenting with different plants and also with technology of how robots or how mechanically you can actually do the planting and different things. There is a 1 megawatt solar power plant that is being installed in IIT, and as I mentioned, there is a lot of rain that we get, but we don't see any flooding on campus because how the drainage system has been maintained. So these are a few other things in terms of the urban design that we are looking at the campus transportation. So the main road which you must have taken yesterday and today is a narrow road, but it allows all kinds of vehicles, all the construction vehicles, buses, cars, people, and it's not very well designed. So can we really make some parts of it vehicle free so that bikers and pedestrians can use it freely? So to do that, we are trying to address it in terms of design as well as understand in real time the air quality, how it is improved, the noise levels, and if we can create a system which can have this main road as a traffic-free road. Again, moving on, we are also looking at, so this is one NGO, Clean Air Island, which is collaborating with the electrical engineering department, looking at how we can, once we remove the cars from the academic area, if we can use electric vehicles that are solar powered to run in the academic campus. There are around 8,500 students and staff that use bicycles, but when they leave, nobody knows what happens to the bikes. So there are areas where, if you see the top picture, the bikes are just kept there and they just rot away. So we are also thinking of implementing a bike share system, which you must have seen in a lot of cities, London, Paris, New York, Montreal. So if we can implement that kind of a system and encourage more bike usage, which is safe and create pedestrian-friendly environments as well. We have very big classrooms. I don't know if you had any classes in the lecture hall complex.
In civil engineering 208,
Okay.
chemical engineering 118, so that part of the.
Okay. So, but there are very big classrooms, almost 150 or 350 seater classrooms. How do you, and people sleep in the class, it could be because they've been partying late, but it could also be because the oxygen levels in the classrooms are low. So what we are doing is trying to, that's an excuse, so you can use that. So we're trying to measure the air quality levels in our campus, because not everything is sealed, the windows are open, there's a lot of construction taking place. So the air quality is impacted by that as well. So trying to measure that and trying to predict the scheduling of the classrooms and also design of different spaces. Here the way these boards are being placed, it kind of restricts everyone to one part of the area. So as I mentioned, there is a lot of construction happening and we are growing. So for next 10 years, the construction is going to happen, and the way, so this is, if you see the lower picture, the lecture hall, which has most of the classes, is on your left, and there is construction happening on your right. And this, you'll actually get, when you go near.
Did you do any tracking of like the cost of materials and construction for your design house versus, say, if that was to be implemented, the cost of a more traditional house?
Yes, all of those calculations have been, and so we have actually looked at the overall life cycle, energy and cost of the house, and we've also looked at the embodied energy of the materials that we are using. So we've tried to be as sustainable as possible, but since there is a constraint of using a prefab kind of material, because you had to disassemble and take it to France and then come back. So we couldn't really use some of the local materials that we would have liked to. But we are doing the analysis based on the materials that could be used when the house comes back or in another buildings. But I don't remember the number. So if you are interested, I can actually put you in touch with the students.
Also, how did you get the house to France? How much did you have to disassemble it?
So this was actually a very logistical thing, because you had to think about how do you design your walls, how big should be the section so that it fits the container that you are planning to ship it in. So that was an exercise that we had to actually redo. First we designed the whole house, and then we thought about the container sizes. So then so our walls were around 3.1 meters, but the container was 2.8. So we had to then break the walls and just have like the top part as a truss, which would be then sitting over the wall. So there were things that we could have thought about earlier to make our life easier or thought about, but finally it happened. And then when we go there, since we have only 10 days to do the entire construction, so everything has been labeled as to which falls in the south, and all the floor panels, wall panels, so that we know exactly what goes where, and it's just students who will be doing this. So we had some help from the fabricators in IIT, but there it will only be students who will be taking care of this. So
For the solar house, did you have to apply to join the program, or was there a grant? Because it sounds like it'd be very expensive.
yeah, so there is this is a team of 70 students and 12 faculty members. And there was a sponsorship team which actually went out to industries, to research organizations, to government to get sponsorship. So we have been able to collect till now at least 90% of the cost of the house, but we are still a little bit short. So we are still looking for more help. So for instance, Jet Airways, which is the Indian airplane company, they have sponsored all the tickets to go to France for 50 tickets basically. So there were 2 workshops earlier, and now there will be 40 people going in summer. So
Now when we take Jet Airways, we'll feel much better.
So similarly, like there's a lot of in-kind support in the material. So Saint-Gobain is one of our main sponsors who have supplied all the wall materials and the window, double glazed window materials. Similarly, air conditioning appliances have been provided by some other companies. Training for construction and health and safety has been given by companies. So that way we have gotten in-kind support as well as cash support. So it's been a 18-month long project. So students, we have tried to actually incorporate some parts of it in the curriculum in project work, but it would be a good activity to actually incorporate it completely in the curriculum because students were struggling with their coursework as well as with this project.
What do you plan to do with the house after you enter the competition? Or is it going to go to like someone to live in afterwards? Or?
So we'll bring it back and we will reconstruct it on campus. So as I mentioned that we will try to use it as a green building laboratory. So there are a few things that we have thought about and as well as the government is pushing us to do is build a prototype for defense personnel or use it as a house, a proper house in campus and try to actually collect data on the operations for a year or 2 so that we know exactly how much energy is being used. It could also be used as a green space, a cafeteria kind of space for students and learn more about the green building. So there are a few ideas that we are tracking now. Okay, you see my calendar here. Any other questions?
Matt, you had one?
I did. My question has to do with the LEED system and how India kind of is involved with it. So you said a couple of the techniques you do with glazing and that kind of stuff gave you LEED credits. And then, so how is LEED kind of applied to a lot of the cities? Like, do a lot of the buildings, are they constructed with the idea that they're going to get LEED credits and they're going to be a LEED accredited platinum or gold or whatever?
So there is LEED India as well, like it's derived from the university's BBC LEED US. So, but what in this house, what we have done is, we have looked at what are the criteria of the LEED. We are not going for any rating, but we have tried to extract those ideas and implement in our house. But there is a LEED system already in India, and there is a in-house developed system, Griha, which is like more Indianized version.
Is it very sought after? Is it subsidized? Like if you reach a certain status or credit, will you get kind of money from the government? Like, or do people constructing buildings not really care too much about the system?
People are starting to get more aware, and all the bigger organizations and builders, they go for LEED credit. So it's more about the status right now. We don't have any government subsidies. If you build a green building, then you don't get anything right now from at the government level.
But you do see some kind of push towards.
There is a lot of, if you actually, I don't know the number, but there are a lot of green buildings that are LEED rated in India and they are increasing, and I think Mumbai may have the highest number.
One thing I was struck by in your presentation was you said that there's a value in being closer to nature, which is something that we haven't actually heard anybody talk about, which I was really appreciative of the fact that it's nice to actually have green space and to live in it. So that's just a comment, which I think, and the idea that human beings need nature to sort of like flourish and thrive. But I was wondering about the gentrification. So we were in Colaba, which is sort of has a colonial small architecture, and which I think probably has a series of demands that would place on you as a planner. And then now it seems like there's new spaces that are opening up. Is it exciting? Is gentrification exciting to you because maybe it represents a chance to do things right, or are you more interested in retrofitting? I guess it's like a professional question for you.
It is kind of a conflict. In my mind personally, I would like a mix of income groups, a mix of people, mix of buildings to coexist. And so I would be against gentrification, but sometimes if gentrification is the only answer to actually provide healthy environment, sanitation, proper sanitation, then it's a difficult choice. But it's kind of inevitable when you improve the areas, the real estate prices go up, and then you drive away the low-income people. So it has to be something the government has to play a role in, where you create these low-income housing. And a lot of countries like New York has affordable housing so every 30% of your development has to be affordable. So there are policies that the government has to sort of include or incorporate to avoid gentrification. Did I answer the question?
I think so, yeah. I guess you meant more along the lines of sprawl, I mean, gentrification is clearly a but you answered the question very well, thank you.
And just on your comment about being closer to nature, as we saw, like people were saying urban heat island because of the lack of green spaces. If we incorporate these green spaces in urban areas, we can actually reduce the urban heat island as well.
I guess kind of going off of the whole idea of having different incomes, how has the process of creating green technology and green buildings and that intersecting with making it affordable for all types of people been? And do you work on cost effectiveness as well as just creating the technology to make a building more green?
So if you look at the Indian vernacular architecture, it is actually inherently much greener than the newer technologies that are coming in, because the building design itself and the materials used make it green, so you don't have to implement like solar panels and other things. In terms of, for this house, we started off with, our goal was sustainability and affordability. So currently, I think we are still sort of targeting the upper middle class. We are not able to with this house because we had to implement all the European standards with dishwasher, all the appliances and everything. So we've not been able to reach the low income standard, but that is also another project that the government is pushing us to take, to build low income housing for rural areas, which is also green. So it is definitely possible because there are technologies. One of the, I think you might visit Indian Institute of Science, I'm not sure, in Bangalore. So they are developing this brick which is very less embodied energy, but it has good properties. It is better than the bricks used. So that is a very low cost material that we could use to create good buildings. So there are technologies that can be developed, but currently if you see the scenario, the upfront cost, capital cost of green buildings is a little bit more than the conventional.
So India has monsoon for 3 to 4 months.
Yeah.
And if this house was to be implemented, how would the design be changed in order to be able to withstand the monsoon in terms of saving the water or not, like having giant tanks for that?
So this house, actually there are competitions that talk about the energy balance, water balance. So we have taken into account water recycling and rainwater harvesting in this house. And in terms of the energy analysis, we have created a design that is applicable for Mumbai. So right now what we built is applicable for France for the 10 days that the competition will be there. So that's how it has been built, but the analysis has been done for a design in the local climate. And we are considering the rainwater harvesting, water recycling. So the water balance in the whole house as well. Am I?
No.
Yes?
You said that there was a slum nearby the campus. Do you have any programs or outreach or projects that are geared towards helping the slum, educating the slum, providing them with resources?
So actually the students themselves form groups, and so there is so it is a student driven program, and there are some faculty who help with the students, but students themselves actually do involve in these activities. In the campus we have of the administration, but there are people who are working towards it.
You were in the US for a while, and now that you're here, are there things that you think would be useful? Well, presumably most of us spend much of our lives in the US. Things that you, like now that you've returned here and are working here, that would be useful for us to be thinking about in terms of, you worked in New York. Like,
Yeah, I think there is a lot of things that I've learned there can be implemented here. One of the things that, it's not like physically design related, but one of the things is the civic sense of people in the US versus here, and how they treat their living environments. So what I've noticed here is that pedestrians are just invisible. People don't even know, okay, if you are in your car or any motorized vehicle, you just don't care about pedestrians at all. So that is something that I've noticed, which is a very negative thing in India, that people really don't value life.